Well, sorry about that. Not quite sure what happened. But anyway, what do you have that you'd like to work on today?
I don't have any specific problems, but we're working on cubic quartic regression.
Okay.
It's already working on. It's pretty easy, but
You've got your finals coming up in a couple weeks.
yeah.
I would suggest, because here's what's going to happen. The Monday before your finals, you're going to come to me and you're going to have 4 hours worth of preparation material.
Yeah.
And there's only going to be a half hour available to you.
Hmm.
So see if you can figure out what the review material that your teacher is going to give you that last week is, and let's start reviewing it now. Because
Okay.
we're really only going to have an hour and a half to review a semester's worth of material. So what's the stuff that you want to go over now?
Um.
Stuff you can verbalize?
Yeah. So it's basically just work with polynomials, factoring.
Okay, give me
uh,
a polynomial. We'll go through it.
Second, let me see if I can find one in my stuff. Oh, can't think of one off the top of my head.
Cubics can be very hard to do
Yeah.
if they do not fit a certain pattern. If you cannot do them by grouping, then it's extremely hard to do them.
Um.
You have to invoke all kinds of radical theorems.
Yeah. So, for example, x cubed minus 13x minus 12.
Minus 12?
Mm-hmm.
All right. So you've clearly had the rational factor theorem and the
Mm-hmm.
zero remainder theorem.
Mm-hmm.
So the rational factor theorem says that if there is a rational factor, its numerator is a factor of 12 and its denominator is a factor of 1. So here are all of the possible choices. This is for the numerator. In other words, those are all the factors of the numerator. And then I would normally have to include the factors of the denominator, but since they're 1, it doesn't change my possibilities. So this tells me there are 12 possible rational zeros for this cubic. And there's no other way to do it unless the problem says you can use your calculator. Yes or no?
Yeah.
Yes, you can use your calculator?
Oh, no, no. I thought you were asking me yes or no. I think this is for synthetic division.
Okay, that means you cannot use your calculator.
Yeah.
What you have to do, this is a trial and error process. These are you see where there's 12 possible answers?
Mm-hmm.
Well, what you do is start trying them one by one. You thought factoring was hard. This is really hard.
Yeah.
The one advantage of this is that you're only going to get one question like this on the test because it's a 20-minute question. Okay? In other words, we don't know which of these answers represents a rational factor, and in fact, none of them might not have a rational factor. Remember what a rational number is. In other words, if square root of 2 is a 0, that's not rational. So the rational factor theorem merely says that if there is a rational factor, its numerator has to be p over q. P has to be a factor of the constant. Q has to be a factor of the coefficient of x cubed.
Mm-hmm.
Well, in this case, that gives you these possibilities. Okay, I've listed them all there. Now, to determine which one works, we're going to do synthetic division, and we're going to hope we get a zero remainder. If we do not get a zero remainder, it is not a factor. That's by definition. That's the zero remainder theorem. So the way I always do these is I do the simplest numbers first. What goes on top if I'm going to do synthetic division?
Sorry, I used to doing synthetic a little bit differently. I don't know.
Well, synthetic division is only done one way. And the top has the coefficients, but you have to allow for every degree of x. In other words, there's a missing x squared, so we have to put a 0 for that x squared.
Oh, okay. I know what you're doing. Okay.
Okay, now we have minus 13 for the x term, minus 12 for the constant. Now we're going to divide that polynomial by 1, which would be an x minus 1 for the linear factor, and hope that we get a 0. We'll not find the rational 0 until we get a 0 here. So how do you do synthetic division here?
So you pull the 1 down.
Okay.
Then multiply 1 by 1, so you have 1. Subtract 0 by 1.
Add. It's always adding. That's
Adding.
That's the beauty of synthetic division, is you get to add and not subtract. If you're doing long division, it's always subtraction. But when you're doing synthetic division, it's addition. And that's the brilliance of synthetic division, is that you get to add.
All right. Negative 12, so you'd get negative 24.
That is not 0. Therefore, 1 is not a solution. So,
Negative 1 looks like it would be.
What's that?
Looking at it, negative 1 looks like it would be.
Well, maybe not. Just because that number was the same wrong sign doesn't mean a whole lot. I mean, you might be right. Let's try negative 1. I've never found that particularly to be true. Huh? In this case, you're absolutely right. All right. So we found our rational factor. Now what? What are the two factors of this cubic that we know? If that is a 0, we just proved that minus 1 is a 0. In other words, if you looked at a graph of this, it would cross the x-axis at minus 1. So that tells us one of the linear factors. What is the linear factor if minus 1 is a 0?
X plus 1.
What's the remaining factor? In other words, that's true. X plus 1 is one of the linear factors. This result we got tells you what the remaining quadratic is.
So x squared x squared minus x minus 12.
Good. And then that is a quadratic that we can factor further. So now we have x plus 1 as one linear factor, and this is going to produce two more linear factors. What are they?
X minus 12, x plus 1.
No.
Oh, no, sorry, x plus 12x minus 1.
No. Cole, you gotta remember how to factor quadratics. There's almost nothing in algebra that's more important to do than that. No matter what test you ever are given, it's going to involve factoring quadratics.
X minus 4, x plus 3.
All right. So your three zeros are x equal minus 1, x equal 4, and x equal minus 3. So in this case, we had 3 rational zeros. And notice that all 3 of those are in our 12 potential answers. And there's really no easier way to do that problem. In other words, who knew that factoring quadratic or cubics would be this hard, but it is. It is a trial and error process, and if I had a 24 here and a 24 there, then all of a sudden it becomes an hour-long problem. Because the numbers of factors of 24 are twice as many as with 12, and I got it in both numerator and denominator. Okay? In other words, let's say I had the numerator read this, and I had the denominator read this. Well, you have to do all combinations. In other words, you have to do that, so 6 would be an answer. 12 would be a possible answer. 1/2 would be a possible answer, and 1 would be a possible answer. So the one we did only had numerator differences. In other words, the denominator was plus or minus 1, so it didn't really affect all of our numerators. But you can see how hard these would be if you had numbers that had lots of different factors. It's a little like factoring quadratics. When you have a number in front of the largest term, the x squared term, it's automatically tougher, right? I mean, it's much easier to factor this because the x squared term has a 1 in front, and that's it. It'd be a lot different if I stuck a 4 there. Now that becomes a difficult factoring problem, a really difficult factoring problem. All right. There are 2 kinds of cubics. Let me give you another one. This is another cubic, okay? And we could use the same logic. We could say, okay, the numerator has to be a factor of 6, and the denominator has to be a factor of 1. But this cubic,
grouping.
Right, a very, very small percentage of cubics you will be able to solve by grouping. And the only reason you can solve it by grouping is because the ratio of this coefficient to this coefficient is the same as the ratio of this coefficient to that coefficient. However, I've made this kind of hard. Let's see if you can figure it out. So what's the next step?
So just cross the line in the middle just for...
Tell me what to write next.
So next, with the left side, the x cubed minus 3x squared, factor out.
Put this in parentheses.
Put in parentheses.
Now,
factor out.
Before we get to that step, I want to make sure you know this, because this is a trap. In other words, I have to put this in parentheses also. Right? What is it?
2x plus 6.
No. That's different than what we're looking at. In other words, that was expression number 1. This is expression number 2. You have to make sure you do not change anything. We'll take expression number 2 and remove this second set of parentheses. What do you get?
Negative 2x plus 6.
You get minus 6. This negative sign has to be distributed to both terms. So do you see where expression number 2 is not the same as expression number 1?
Mm-hmm.
And the only way to make it the same is by changing that to a minus 6.
Oh, yeah. Okay.
And that's the trap that almost every single person makes. And the only time you have to really watch for it is when that is a negative sign. If that's a plus sign, you're never going to have the problem. But if that's a negative sign where you have to put parentheses around the two terms on the right, you have to be very, very careful.
Okay.
And the secret, as I've said many, many times, is that when you are manipulating an expression, when you are not changing it, make sure that at every single step you check to make sure you have not changed it. Well, at this point, 2 is the same as 1. Now factor your stuff out.
So on the left expression, you can factor out an x squared.
Leaving.
And get x minus 3.
And on the right?
You'd get factor out a 2, and you get x minus 3.
Now, that's the key. Notice that x minus 3 and that x minus 3. They have to be the same if we're going to continue on with this problem. So, had you made the mistake that almost everybody makes and put a plus sign there, you would have gotten x plus 3. That should be your red flag. That should tell you you made a mistake. The only way grouping ever works is if this binomial term is the same as this binomial term, because our next step is to factor out that binomial term. Okay? So it's one thing is if you do make the mistake, you will see these two binomial terms won't be the same. Okay? Now what?
So now you reformat it, since x minus 3 is the same, so then you write, the next line is parentheses x squared minus 2.
Well, let's think about it a little differently. I'm factoring out an x minus 3. That's what I'm doing. And when you factor something out, you put it first.
Okay.
Basically what I'm doing is dividing both sides by x minus 3. When I factor something out, that's what I'm doing. And what's left?
X squared minus 2.
Yeah. Now.
You can go that further because that's difference of perfect squares.
Okay, so how does that factor?
No, it's not. Never mind.
Well, you're right, actually. You probably got that from me. That can be factored. That is, if that is an irreducible quadratic, and the definition of an irreducible quadratic is one where it only has imaginary solutions. Well, this does not have imaginary solutions. This has real solutions, and they are x minus square root of 2 times x plus square root of 2.
Okay.
So there are your 3 zeros. X equal 3, x equal root 2, and x equal minus root 2. Now, the bottom two are irrational, but they're still real. The top one is real and rational. But the only time you do not take that quadratic further down is if it has only imaginary solutions. In other words, if that ended up being x squared plus 2, that is an irreducible quadratic. I cannot factor it with anything but imaginary solutions, and therefore I leave it like that, and that's my answer. You do not have to worry about irreducible quadratics. But if they are quadratics that have real solutions, not complex ones, then you do go ahead and factor it, just like I did here, into that and that. And what you said was difference of perfect squares. Well, it isn't difference of perfect squares, but guess what? It doesn't need to be. Difference of squares is what it really should be called.
Mm-hmm.
It's only in Algebra 1 and maybe geometry that they call it difference of perfect squares. Guess what? If I have the expression x minus 7, that factors. Factors into square root of x minus square root of 7 times square root of x plus square root of 7. So it factors even though neither of those are perfect squares. So it's really the difference of squares is what it should be called. And it can be applied anywhere where you have a minus sign in between two terms. And that's why I say I'm one of the few people that probably would have mentioned that to you. If you didn't recognize that as the difference of squares, you could always use the quadratic formula to come up with these two solutions. The quadratic formula would have given you square root of 2 and minus square root of 2. Okay?
Mm-hmm.
But recognizing it as the difference of squares is quite a bit faster than applying the quadratic formula, granted? In other words, if you recognize that as the difference of squares, it immediately goes to x minus root 2 times x plus root 2. So that's a great step to recognize. All right. I'm going to let you go and try to figure out what the heck. I guess I gotta just go in and delete the phone number I have for that other Cole White. I don't even know how I got it in my phone. Is this the phone?
3226.
Yeah.
Yeah, I changed that number earlier this year.
Wow. I guess we haven't had very many sessions since then. So, okay, I'll change it to the new one. The one I just...
Oh, you've been sending me that up until like...
Yeah, no, I had you in here.
Messages from you, fine.
When you texted me, are we having a session tonight, it said Cole White. So I have your new phone number in there, but apparently I didn't get rid of the old one and accidentally have been texting the old one. So I apologize. I will from now on use this number here.
It's all good. I just wanted to make sure because I was just sitting at the computer. And...
Well, I'm glad you did. Thank you. Otherwise, I would have just assumed that, I don't know. I would have tried to figure out what the heck was going on. All right, Cole. Talk to you next Monday, and I will definitely use this number.
All right, sounds good. Thanks.